Alright, so we're going to look at examples number 2. Tangent of 15 degrees. So that's not something off the unit circle that we know, so we need to come up with 2 other known values that either add or subtract to give you 15. So, what would that be?
45 minus 30.
Okay, and obviously there's a lot of options you could use. Could do like 60 minus 45. There's a ton of options you can use pretty much for any of these, but I always like to try to pick the easiest ones if possible. So, tangent of 45 minus 30. And obviously because these are like a fraction and a fraction, the tangent ones are going to be harder than the other ones, but they're still not that bad. So we fill this in. So this is going to be the tangent of 45, same sign on the top, minus the tangent of 30 over 1, opposite sign, plus tangent of 45, tangent of 30.
What do you mean opposite sign?
Like, so initially we had a minus here, so it's the same one here, and the bottom it's opposite.
Okay. You're thinking sine and cosine.
Yeah, I was.
So the tangent of 45 is what?
1.
Minus tangent of 30?
Ew.
Square root of 3 over 3.
All over 1 plus tangent of 45 is 1 times tangent of 30 is root 3 over 3.
So then the top one, you'd have to have the same
I need to get a common denominator.
So it's 3 over 3.
So I'm going to loop down here so I can work my way across. So I'm going to do 3 minus root 3 over 3 on top. Okay, I'm just going ahead and making it 1 instead of having to do 2 separate steps. And then on the bottom, because this is like root 3 over 3 plus 1, I'm going to do 3 plus root 3 over 3.
You train slow.
So 3 minus root 3 over 3 times 3 over 3 plus root 3. So 3's cancel. 3 minus root 3 over 3 plus root 3. But I can't leave my answer like that, so what do I need to do?
You reduce the 3's, right?
Can't do that.
You have to multiply by the square root of 3 on top.
You have to multiply
It's
by
not going to completely help me.
Is it 3 minus the square root of 3 over 3 minus the square root of 3?
Yep, so I want to multiply by the conjugate, so 3 minus the square root of 3 over 3 minus the square root of 3. Okay, because on the bottom I want to get a difference of squares, because if I did just the square root of 3, I would still have 3 root 3 plus 3.
Oh, okay.
So I would still end up with a square root on the bottom, which I can't have. So this way, I now have something I can work with. So I'm going to loop back over here. So on top,
All of my homework's going to look like these loopy things.
9 minus 2 square root of 3, I have a perfect square trinomial on top, plus 3 over difference of squares, so it's going to be 9 minus 3. So then 12 minus 2 root 3 over 6. I can take a 2 out of both things on the top, so that's going to be 2 times 6 minus the square root of 3 over 6. 2 and the 6 can reduce to 6 minus the square root of 3 over 3.
Oh goodness, is that the answer?
Yep.
That was a lot. That was a lot. Like, it's not necessarily hard to roll things. But, okay, that's a lot. Okay.
Just a lot of little algebra steps with the trig ones, with the tangent ones.
Is the homework for this going to be due Wednesday? Like, or are you going to assign some tonight, Jane?
I don't know yet. We'll see how much we get through. All right, for cosine of 75 degrees. So what two things can I add together to give me 75? Or subtract to give me 75?
45 and 30.
45 and 30, so cosine of 45 plus 30. So cosine 45, cosine 30, opposite sign, so minus sine 45, sine 30. Cosine of 45 is root 2 over 2. Cosine of 30, square root 3 over 2. Minus sine of 45, square root 2 over 2. And sine of 30. So then I just need to simplify this. So square root of 2 times the square root of 3 is square root of 6. And then since they're both 2's, like both are 2's on the bottom, it's going to be 4. So I'm just going to do this as one step to save a step of writing. Minus square root of 2 times 1, just a square root of 2. And so then that's your answer.
That's it?
Yep.
Okay, I'm a little light here.
Cosine and sine are definitely easier than tangent.
Cool.
I'm still writing the problem down. I fell a little bit behind.
And I will just give you a unit circle for this stuff. And when you get to the exam, I'll just give you a unit circle. You won't have to like write it down or anything.
I'm guessing that having all your testing is at 5 points like it usually is on the exam.
Probably.
Your hair looks really long.
Mine? Thanks.
All right, so 6 is going to be the sine of 7 pi over 12. So with this one, Kay, part of why I said convert radians to degrees to make your life easier is because I don't necessarily think that off the top of your head you know two angles that add up to equal 7 pi over 12 without a lot of effort, because that's not something on our unit circle, like increments of pi over 12s. Not that you couldn't figure it out, but that just seems like a lot of work. So we'll convert radians to degrees. So how do I do that?
7 pi over 12 times, or like the bridge thingy, yeah.
Over 180.
180 over pi.
I mean, that's what I meant. Yeah.
And then calculator, guys.
I'll just tell you it's equal to 105.
Terrific.
Terrific.
So the sine of 105, not something that we know.
So.
So I need to find two things that either add or subtract to give me that.
Well, we have
60 and 45. Oh, that works too. Alright.
So sine of 60 plus 45. Make sure you always verify that the two angles that you use do actually add up to it. Sometimes people pick two that they don't actually end up adding up, and it's sometimes kind of funny.
That's something
that would be funny.
So I'm like, those two don't even add up to equal that. And they're like, oh. They're like, I forgot about that part. So
Me too.
just make sure you always go back and look and be like, oh yeah, this does work or whatever. More so with the subtracting ones, like you do have your calculator, so verify them. Anyways, all right, so then sine
of 60.
Have the cosine of 45 plus
sine is the same sign.
cosine of 60 sine of 45. I didn't make the numbers with that.
Whoa.
Square root 3 over 2 times square root 2 over 2 plus the 1/2 times square root 2 over 2.
So then,
Same thing as last time.
yep, square root of 6 plus square root of 2 over 4. So pretty much all the sine and cosine ones are going to look like this.
Nice.
Like that answer is just the same process.
How about
The numbers that are involved in the answer are pretty much always going to be like that. As long as you're using, there are other problems that you might remember doing in Algebra 2 that we used like this formula for, but we did a different thing where you actually solved the values on a triangle and then plugged them in. That's a little bit different, but
We're not doing that, are we?
no.
Good.
That's just gonna say yes.
What time is it?
We have like 3 minutes.
9, 10.
Oh wait, sorry.
We
We have
have
like
7
6 minutes.
All right, so that's going one direction, but you also could have to potentially go the other direction, but it's actually way
But that
easier.
love and affection.
Or One Direction.
People laughed and I was so happy. I was like, thank goodness Andrews, like, they thought it was funny.
Some people were like,
Like, I shouldn't have put it in there. Or
no,
just, like,
they were just like, I can't believe it, like that he likes that.
And he
Like,
tried to cover it up. I was like, no, Steve. Like, you
We
didn't
all
really-
know you do. And it's on the video, man. That's awesome.
I literally, Miss Patton was like, Hope, you should have, like, hit play and just had, like, something playing. I was like, I would, but I feel like that'd take too long. But it was,
I also think that the donuts in the parking lot after a win, I think some people may have thought you actually meant like edible donuts.
Well, that's
Yeah.
probably good.
Yeah, that's probably a good thing, though.
Because like
Hopefully Mr. Law knows. Like, I mean, they know, so, like, what does it matter? Like, I know, because Mr. Law was like, make sure you don't put anything in there that's going to get in trouble, and I'm like, I'm not. But I thought it was funny, and people did laugh, and I was like, good.
All right, so this problem is the reverse.
oh, I see what you mean. I mean, I don't really
Then
understand.
it's cosine of 94 plus 18 minus 18.
Cosine of 94 minus 18.
Oh, okay.
Okay, you have to look at whatever you started with and think, okay, what formula, like, what reverse formula gives me that? So cosine of 94 minus 18 is equal to the cosine of 76. What?
Nothing. I'm just stupid.
No,
How did you get
I
76?
literally did not get it.
94 minus
Oh.
18, honey. What's going on? Are you feeling
No,
okay?
I'm not. I'm literally like so sleepy. Like I don't.
I am too. My hand is in that. Have you?
I
Has your
literally
hand
have-
ever felt like it just like?
I didn't go to bed till 1 a.m.
Yes.
I didn't.
That's
sleep.
how
I was a little preoccupied. Oh, that just sounds. Well, my brain was a little preoccupied.
I'm done.
I'm good.
I'm done.
No, it was a good. It was good. It was a good. It was a good preoccupied.
That doesn't mean anything when it comes from your mouth.
No, I know what she's
It
talking
was
about.
good.
It's
It
fine.
was her fault, but it was good. Why do you blame
It
everyone
is
else?
not my fault.
No, it's not your fault. You're correct. But it could have been. She encouraged it.
I understand. I understand that.
I do not want to be associated with that.
I don't want to be associated with it either.
None of us wanna be
Ew,
associated
not
with you.
radiant.
Oh, I thought you were gonna say something pertaining to this.
Okay.
All right, this one, just leave them as radians because we'll just get a common denominator and it'll be way easier.
Sine of pi over 3 minus pi over 7.
Yep, and then we want to get a common denominator.
Just make the
21.
So 7 pi over 21 minus 3 pi over 21, which is the sine of 4 pi over 21.
And then,
Done.
oh, is that it? You don't have to convert it to.
You go done.
No. I mean, you could have converted this one from the beginning if you wanted, but I knew it would take longer to do that rather than just getting a common denominator. But if you did switch it, that would be, like, I wouldn't care.
Oh, no.
Questions,
God,
notes.
you just gave me a stroke.
The only thing that's not done is I have to make the quiz all in one thing and then make sure.
Y'all okay with this section?
Yeah, this isn't difficult.
Great.
Pretty good.
Sounds good.
If I say it's not difficult, then I speak for everyone. I'm just
Homework.
out of brain cells with this.
Oh dear God, help us.
3, 5, 7.
I'm done.
She was like, here's a pause between every word too. She was like,
13 and 15.
Dear God, help